Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today I want to discuss about some selected topics related to this engineering tribology. So already we have discussed about various topics in engineering tribology, various modules, module 1 to module 5 we have discussed related to this in tribology parameters like friction, wear, lubrication and corrosion and engineering materials. But in this session, we will see some topics, the selective topics. Already in previous session we have seen selective topics 1. So now we will see 2 and then 3 in coming up sessions we will discuss. So in this today I want to discuss about the topics is the selective topic is titanium alloys. So the titanium alloys comes under this engineering materials. So engineering materials different materials are there. The classification of materials we have seen and studied in engineering materials. Now in this the titanium alloys, what is the titanium alloys composition and then what are the applications and what are the important application and what are the advantages and disadvantages we will see. So in this the explain types of titanium alloy and then list out the advantages. So types of titanium alloys, first the concentration. So concentration is titanium, types of titanium alloys. The commercially the pure is titanium, the commercially pure, that is CP is titanium grades are available 1, 2, 3, 4. The composition is essentially pure titanium with minor amounts of oxygen and iron. And similarly, the alpha alloys, the grades are tin, 5 aluminum and 2.5% of lead, and then Ti, Ea8Al, 1 molybdenum, 1 vanadium, Ti, 6Al, 2 tin, 4 zirconium, 2 molybdenum. The composition is primarily aluminum and tin with the traces of other elements like molybdenum and zirconium too. So in this the composition is primarily aluminum and tin with the trace of other elements. The alpha beta alloys. So the alpha beta alloys grades are tin, 6 aluminum and 4 vanadium, titanium 6Al and 6V and 2 lead. And similarly in alpha alloys Ti 6Al, 2 Sn and 4 zirconium, 6 molybdenum. The composition is a mixture of alpha and beta stabilizers like aluminum, vanadium, tin, zirconium and molybdenum. Yeah. So beta alloys. Next beta alloys are grades 10 vanadium, 2 ferrous and 3 Al. Ti, Al and 8V vanadium and ferrous is a composition given in this grade. That contains higher amounts of beta stabilizers like vanadium, chromium, molybdenum and zirconium. So advantages of titanium alloys are high strength to weight ratio. So titanium alloys have excellent strength while being significantly lighter than steel. The corrosion resistance, high resistance to corrosion in various environments, including sea water and acidic conditions. So the biocompatibility, so non-toxic and compatible with human tissues, making them ideal for medical implants. Next, high melting point, capable of withstanding high temperatures, making them suitable for aerospace applications. In aerospace application required more high resistance and high corrosion resistance material properties required. So the melting withstanding high temperature, this material having, so that's why used in aerospace applications. The fatigue resistance, the superior fatigue strength compared to other metals, which is crucial for components like subjected to cyclic loading. You know, the fatigue property is mechanical property. So whenever the component is subject to cyclic loading, the component will fail after a certain number of cycles due to the yield stress. The creep resistance is good resistance to creep at high temperatures, maintaining strength and stability under prolonged stress. Next, applications of titanium alloy. So, aerospace. So, titanium alloys are used in aerospace, aircraft frames, jet engines, and space exploration vehicles due to their high strength and low weight, and medical implants, prosthetics, and surgical instruments because of their biocompatibility and non-toxic nature. Submarine components, shipboards, offshore structures for their excellent corrosion resistance in seawater. Similarly, chemical processing, equipment exposed to harsh chemicals such as heat exchangers and reactor vessels. So the automotive, high performance automotive parts like exhaust systems and engine components. Next, aerospace applications. In aircraft components, titanium alloys are used in the manufacturing of critical aircraft components. In aircraft components, these materials are used for manufacturing of critical components like engine parts, airframes, and landing gears. So, due to their high strength to weight ratio, the corrosion resistance and ability to withstand high temperatures. The spacecraft, their lightweight and strong properties make them ideal for spacecraft structures and components. Medical applications, implants and prosthetics, so that is titanium alloys are biocompatible property. So meaning they are not harmful or toxic to living tissues, making them ideal for surgical implants like hip and knee replacements and dental implants and prosthetic devices. So this material is biocompatibility property with the human body. So that's why this material is used in medical applications. Similarly, surgical instruments. These alloys are used to make surgical tools because they are non-magnetic, resist corrosion from bodily fluids. Next, industrial applications. Chemical processing equipment, due to their excellent corrosion resistance, titanium alloys are used in chemical processing plants for tanks, heat exchangers, and piping systems. The power generation is they are used in components of power plants, including nuclear power plants, due to their ability to withstand high temperature and corrosion. So, whereas in marine applications, marine hardware, so titanium alloys are used in the construction of ship hulls, propeller shafts, and other marine hardware because of their resistance to seawater corrosion. So offshore structures, they are also used in offshore oil and gas rigs for various structural components. So automotive applications are high performance parts like engine valves, connecting rods, and exhaust systems due to their strength, and then lightweight nature and resistance to high temperature. The sports equipment. so golf clubs and bicycles. The lightweight and strong properties of titanium alloys make them ideal for high performance sports equipment, including golf clubs, bicycle frames, and tennis rackets. These are lightweight and strong properties. So that's why this material is used in sports equipments. The consumer electronics, our laptops, and mobile devices. So titanium alloys are used in the casing of high-end laptops and mobile devices to provide strength and durability while keeping the weight low. Next, jewelry items. So the this one is titanium aesthetic appeal. The look wise having a very pleasant look, and this one is appearance. The appearance is good. So lightweight nature and hypoallergenic properties make it a proper popular choice for jewelry and watchmaking. So what is the difference between these alpha and beta alloys? So in starting, we have discussed about alpha and beta alloys. So in alpha alloys composition are alpha alloys will contain elements like aluminum and oxygen, which stabilize the alpha phase. These alloys may also include small amounts of beta stabilizers like vanadium or molybdenum, but not enough to form significant amounts of beta phase. So the microstructure, that is phase, predominantly alpha phase, the hexagonal closed packed crystal structure. And stability, the alpha phase is stable at room temperature and up to relatively high temperature. So having this that much of stability. Next, properties, generally lower than beta alloys but can be improved with alloying and heat treatment. Ductility, higher ductility and toughness compared to beta alloys. Corrosion resistance, excellent, especially in oxidizing environments. And keep resistance, good resistance to creep at high temperature. These all are mechanical related properties. You have studied in the materials properties. So in applications, high temperature applications. So due to good creep resistance, they are used in applications like jet engine components. The aerospace and marine used in airframes, landing gear, and marine applications where corrosion resistance is critical. So that's why these materials are used in the aerospace and marine applications, and wherever high temperature resistance is required. So there also these materials are used. The beta alloys. Alloying elements are beta alloy elements main like vanadium, molybdenum, niobium, and chromium which stabilize the beta phase. The microstructure, the phase is predominantly beta phase, that is body centered cubic crystal structure, BCC. So the beta phase is stable at high temperatures but can transform to alpha or alpha beta phases at lower temperatures. Properties, same similarly in alpha alloys, strength, ductility, corrosion resistance, and workability can be heat treated to achieve a wide range of mechanical properties. The strength, the higher strength compared to alpha and alpha beta alloys, especially after heat treatment. So ductility also having lower ductility and toughness compared to alpha alloys. The applications are high strength applications. So used where high strength to weight ratio is required, essential, such as in aerospace fasteners and landing gear. Medical devices used in surgical implants and other medical devices due to good biocompatibility and strength. So next, various properties of ceramics. So very important, these mechanical properties. One is hardness. So already you know. So make them the resistance to wear and abrasion. This property often used in cutting tools. And similarly, brittleness. So ceramics tend to be brittle. So meaning they can fracture or shatter under stress without significant plastic deformation. This limits their use in applications where impact resistance is required. Strength. Ceramics can exhibit high compressive strength but are often weaker in tension and shear. The strength of ceramics can vary significantly based on their composition and microstructure. Next, elasticity property. So these ceramics typically have a high modulus of elasticity. So meaning they are very stiff and do not deform easily under load. And then thermal properties. Thermal properties are high melting point. So most ceramics have high melting points, making them suitable for high temperature applications such as furnace linings and thermal barriers. The thermal insulation, high melting point and thermal insulation and thermal expansion, all these are related to these thermal properties. Thermal insulation, many ceramics are excellent thermal insulators. Why? Because due to their low thermal conductivity property. So this makes them ideal for use in applications requiring thermal insulation, such as heat shields and insulators. So thermal expansion, ceramics generally have low coefficient of thermal expansion. So it means they do not expand or contract significantly with temperature changes. So due to this property, it helps to prevent thermal shock. So electrical properties, electrical insulation and piezoelectricity and semiconducting properties. Next, chemical properties, corrosion resistance, inertness. So already we have discussed about corrosion. So ceramics are generally highly resistant to corrosion and chemical attack even at high temperatures. So this makes them ideal for use in chemically harsh environments such as chemical processing equipment and medical implants. So that's why due to this impact, due to this chemical processing, the medical implants and bone transplantation, that some materials are used. So that material should having this corrosion resistance property. So that's why ceramics are having that property. Inertness, ceramics are often chemically inert, meaning they do not react easily with other materials. This property in applications where the property is important in applications where material stability is crucial, such as in biomedical implants and containers for radioactive materials. Physical properties, density. The density of ceramics can vary widely. Some ceramics are very dense and heavy, while others like formed ceramics and are lightweight. Porosity. Ceramics can be engineered to have a varying degrees of porosity. The porous ceramics are used in applications such as filters and catalyst supports. Next, optical properties. Transparency or opacity. So it means some ceramics, like certain glasses and sapphire, can be transparent or translucent. Translucent or transparent, making them useful in optical applications such as lenses and windows. The other ceramics are opaque and are used in applications where transparency is not required. Refractivity. Ceramics can have high refractive indices, which is beneficial in optical devices like lenses and prisms. So these are the important topic in selective topics 2. So titanium, alloys and properties of different materials. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.